Hi, welcome to my video on the explanation of finding the slope of a tangent. Find the slope of a tangent at 2 when y equals x squared. Notice that y equals x squared is a parabola. So when x is 0, put a 0 in, y is 0. When x is 1, put a 1 in, you get 1. When x is 2, you put 2 in, you get x is 4. And also when you put a negative 1 in, here you get 1. When you put a negative 2 in this equation, you get 4, which is negative 2 gives you a 4. So y equals x squared is a parabola. So we want to find the average rate of change of the slope from 0 to 2. So the average rate of change is the slope of the secant. So that's the slope of the secant between x's 0 and 2. So if x is 0, put a 0 in here, we get y equals 0 gives you 0. So that's the point 0, 0. When x equals 2, we get x is 2, y is 4. You put 2 in here, you get a 4. So that's the point 2, 4. So we got the point 0, 0. We got the point 2, 4. So we're trying to find the slope of the, I'm drawing a freehand here now. We're trying to find the slope of this line, which is the secant. So the slope of the secant is y2, which is 4, minus y1 is 0, over 2, subtract 0. So that's 4 over 2, which is 2. So the slope of this line is, this secant is 2. Okay, now let's look at, find the slope of the tangent at 2. Okay, but this time we're going to find the average rate of change from 1 to 2. So again, the average rate of change is the slope of the secant, and x equals 1. If x is 1, y is 1. So that's the point 1, 1. If x is 2, we just worked that out, x is 2, y is 4. So that's the point 2, 4. So this is the point 1, 1. When x is 1, this is this point, and 2. So we're looking at the slope of this secant going through these 2 points. So this is the secant we're talking about. So the slope of that secant is y2 minus y1 over x2 minus x1. So that's 3 over 1 or 3. So the slope of this line, which is the secant, is 3. And we'll continue. So notice I did a 0 to a 2. Now I'm doing a 1 to a 2. So I'm moving closer and closer to this value of x. So I'm going this way. I'm going to the right. So let's get closer and closer to 2. So now we're going to look at the same parabola, the average rate of change of the slope from 1.5 to 2. Again, when we're looking at the slope of the secant, which is a line that passes through a curve at 2 points. So x is 1.5. So notice we did a 0, and now we did a 1. Now we're doing a 1.5. So, and then we're going to look at x equals 2. So 1.5 is y equals 1.5 squared. And 1.5 squared is 2.25. So that's the point 1.5. Give me 2.25. And this is 2. That gives me a 4. So that's the point 0.24. So the slope of this secant, so let's estimate. So 1.5 is here and 2.25. Let's go up. Let's say it's right there. So that's right there. So this is the point right here, there it is, and 4. So there it is. So we're looking at the slope of the secant. Okay, notice we're getting closer and closer to 2. So the slope of this secant is y2 minus y1 over x2 minus x1. So that's, when you subtract, you get 1.75 over 0.5. And when you divide that out, you get 3.5. So the slope of this line is 3.5. And again, you can see that this, the closer and closer I move to 2, this secant, the slope is getting greater, larger, and larger, and larger. And the first one, we had the slope was 2, then we had a 3, now we got a 3.5. So let's continue, let's get closer and closer. So now we're going to look at the average rate of change of the slope from 1.9 to 2. Again, we're looking at the slope of the secant, which is the line cutting the curve at 2 points. So we have x equals 1.9, and we have x equals 2. We know what 2 is. 2 squared is a 4. 2 gives us a 4. And so we know what that point is because we worked it out. So now we got to go y equals, that's an x squared, so it's a 1.9 squared. And 1.9 squared is 3.61. And so that point is 1.9 bracket 3.61. Again, you use your calculator to square this. And we have to get the slope of the secant between these 2 points. So 1.9 is, there's a 1, there's a 2, 1.9 is right here. So if you go up to 1.9 is 3.6. So it's, there's 3.5, 3.61 is right there. So we have this point, and we have the point 2,4. So now we got to draw this secant. So there's the secant. There it is. Cutting the secant is the line that cuts the curve at 2 points. So these are the 2 points here. So let's find the slope of this secant. So we have a 4 minus 3.61, 2 minus 1.9. And that gives us 0.39 and 0.1. And when you divide that out, you get 3.9. Okay, so the slope of this secant is 3.9. It's getting higher and higher. So the last one was 3.5. This one is 3.9. So it's getting, so the closer and closer I get to this 2, this slope of the secant here is getting higher and higher. What is approaching? Well, let's try one more and see what is approaching. Here we go. Find the average rate of change of the slope from, so we're going from 1.99 and we're going to a 2. And remember, the average rate of change is the slope, but here is between these 2 points, so we're finding the slope of the secant. You find the slope of a secant between 2 points on the curve. And so x is 2, so we know that y is 4. We worked that one out previously. Again, put a 2 in. 2 squared is 4. Now we're putting y equals x squared, so we're putting 1.99 being squared. Take your calculator, and you work that out. You get 3.960. So notice what I do. I work it out for each individual one. Write it as an ordered pair like this. This is the fundamental way that I do it, and I won't make an error this way. Now I say I'm going to find the slope of the secant between these two. So it's a y2, 4, minus y1, 3.9601. x2 is 2, x1 is 1.99. And when you subtract with a calculator, that gives us 0.0399. When you subtract here, you get decimal 0.1. When you divide this, dividing by here, the decimal moves 2 places to the right, so you get 3.99. So where is this point? So 1.99. So 1.9 is here. 1.99 is very, very close. So it's 3.96. So 3.96 is very close. And there it is. There's the other point. So this is 2, 4. This is 1.99, giving me 3.96. So the two of them are very, very close together. So the secant is the line that passes through these 2 points. And notice the points are getting closer and closer. So this is 3.99. And if you look at it closely, these 2 points are getting so close together. So this secant looks like it's approaching the tangent. So if I went closer and closer to the 2, the closer I get to 2, the closer these 2 points are together. Eventually, when I hit 2, this is the point where it'd be just 1 point, and you'll have a tangent. So let's look. As the value of x comes closer to 2, the slope of the secant comes closer to the slope of the tangent. So the closer I get to 2, the secant is becoming the tangent. So the slope of the tangent at x equals 2 on the graph of y equals x squared. Remember, we had a 2, and then we had a 3, and we had a, go back and just check now. We had a 2, a 3, and a 3.5. We had a 3.9. And just then, we got a 3.99. So the slope of the tangent is getting closer and closer to. What would happen if we use decimal 001 and worked it out? We'd probably get 3.999, noticing this pattern. And what's that approaching? Looks like it's approaching 4. So the slope of the tangent at any value of x on the graph or the curve is called and we're going to call it the instantaneous rate of change at that value of x. So the instantaneous rate of change at a point, at a value of x, which means at a point, is the slope of the tangent to that curve at that value of x, or at that point. So notice, again, repeat, the average rate of change is the slope of the secant between 2 points. But the instantaneous rate of change is the slope of the tangent at that point. The slope of the tangent. We keep practicing and going over that over and over and over. Repeat, the average rate of change is between 2 points. Instantaneous rate of change is at 1 point, which is the slope of the tangent at that point. Hopefully you enjoyed my video, and if you did, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. One word. Thank you for viewing my video. Hope the video helped you. Bye-bye.